Consider the function cube root of x. Need to find degree 2 Taylor polynomial for this function f centered at 8 and use the polynomial you found in part A to approximate the value of cube root of 7. So Taylor polynomial just comes from Taylor series, and we know that for a function its Taylor series is just Cn x minus center raised to n from 0 through infinity, where Cn's are found by nth derivative of the function evaluated at the center divided by n factorial. So degree 2 polynomial means we just take n equals 0, 1, 2. So x minus a squared, that will give us degree 2. Okay, so t2x will be, if we expand this, just take n equals 0, we get c naught x minus a raised to 0, which is just 1, plus take n equals 1, c1 x minus a raised to 1 plus c2 x minus a squared. So that's it. And in our case the center is 8, so that is c naught plus c1 x minus 8 plus c2 x minus 8 squared. All we need to find now is c naught, c1 and c2 using this formula. So for let's make a table. So n values, so we have 3 of them, 0, 1 and 2, and we need to find nth derivative of the function. So we need more room, I believe, so let me use this way. Nth derivative of the function, then we need to evaluate nth derivative at the center, which is 8 in our case. After that, we are here, we find Cn's, which is c naught, c1 and c2. So 0th derivative of the function, so n equals 0 means 0th derivative, which is the function itself, that is cube root of x. Now we replace x by 8, evaluate means use calculator, 1 cube root, that's 2. So c naught is just 2 over 0 factorial. 0 factorial is 1, just 2. Now 1 means 1 derivative of the function. Find the derivative of this function. So cube root of x means x raised to 1/3. Its derivative is 1/3 x, 1/3 minus 1, negative 2/3. So it's going to be 1/3 x raised to negative 2/3. Okay, now evaluate at 8. Plug in 8 here. So 1/3, 8 raised to negative 2/3, 1/3, put on the bottom because negative exponent here. That means 8 raised to 2/3 on the bottom, 1 over 3 times, use your calculator, it's 4. 4 times 3, 12. So 1 over 12. So C1 is 1 over 12 divided by 1 factorial, which is itself. Now 2 means find its derivative. Second derivative means derivative of first derivative. 1/3 times negative 2/3 x raised to negative 2/3 minus 1, negative 5/3. That is negative 2 over 9 x raised to negative 5/3. So this is negative 2 over 9 x raised to negative 5/3. In fact, you don't have to show this table. You can just go from there. Next, we need to evaluate at 8. Okay, just plug in 8 here. So negative 2/9, 8 raised to negative 5/3. 2 over 9, 8 raised to 5/3, use your calculator, negative 2 over, okay, just multiply 2 fifth, 32 times 2, 288. So negative 2 over 288. I'm not going to simplify because I have to do something to find C2. Okay, so C2 is then this divided by 2 factorial. 2 factorial is just 2. Divide by 2 means put 2 on the bottom. So negative 2 over 288 times 2. Now cancel 2 and 2. So that negative 1 over 288. Okay, now we got all constants. So we plug in here and find T2. Thus, degree 2 Taylor polynomial is C0, which is 2 plus C1, 1 over 12, x minus center, plus C3, that is negative 1 over 288, x minus 8 squared. Okay, that's part A. Now, we need to use this polynomial to approximate the value of cube root of 7. Here is the question, cube root of 7. Simply replace ax by 7. Okay, so cube root of 7 will be approximated by this Taylor, degree 2 Taylor polynomial evaluated at 7. So all you have to do is plug in 7, done. 2 plus 1 over 12, 7 minus 8, minus 1 over 288, 7 minus 8 squared, 2 plus 1 over 12. Okay, and here this is negative 1 minus 7 minus 8, negative 1 squared, positive 1, 1 times this is just this. Now use your calculator and it comes out to be 1.91319. How many decimal places? Depending on the question. If question asks for 4, you need to round to 4. Okay, final.